So in this video we are going to discuss about the pin diagram of 8051. So it has 40 pins. If you have seen my last video, you have probably no fear then, because I told you that what are all 32 pins about, and remaining 8 we will see now. So this diagram can literally haunt you and make you cry, because you are in a good mood and you suddenly open the book and you see this much structure. It appears to be way hard, but it is completely simple. So let's start without wasting any further time. So let us go one by one, right? So there are 40 pins separated into two parts. They are actually not separated, but as a way of explaining, I am telling that 32 pins are consumed in these ports and the rest 8 pins are there. So that's all we want to study. So let's begin with the order. So let's start with a clock now. Now microcontroller has to do various functions, not various but a few functions. Okay, so definitely when a function or a program is to be executed or a memory is to be saved, there should be a time factor. Okay, there should be a time factor, like at this time this is this, at this time this is this. So we know time. We have a watch, we have a clock, we can see the time. But what is a time for a microprocessor or a microcontroller? Who gives time? So there is basically a clock which is supplied. Okay, what is this? A clock. So here I assume that you have zero basic knowledge. Okay, I don't assume that you already know, you are a scholar, because if my assumption goes wrong, then you will literally understand nothing. So I assume that you have no knowledge. So there is a clock. What this clock does, it creates such a waveform. This is the output waveform of a clock. Okay, so this goes on continuously this goes on moving, and from this end to this end, say there is one wavelength, as we used to do in crest or trough. So it realizes, okay, so this is this much time, this is this much time. So there is a clock signal which is given to the microcontroller so that it can understand the concept of time. So here is that clock input. But how, like how we can supply it? So what we do is take a crystal, an oscillating crystal. So as crystal oscillates, we define that if crystal completes 10 oscillation, then it is 1 second. Okay, so when crystal completes 20, it will be 2 seconds. So that crystal is applied, it's kept here, and it's an oscillating crystal. Now not going into the details of the crystal. So here is a crystal which is oscillating with certain frequency. So okay, we have a frequency, so definitely inverse of it is time period. So that was our actual aim. So here crystal is oscillating with the frequency of 12 megahertz. Now I know it's very hard to believe, because our eyes actually cannot see, but the tube light, the light which appears from the tube light, is also not continuous, but it is oscillating with a very high frequency. So here is that crystals. So that two pins are connected to that crystal, which are named as XTAL1 and XTAL2. So that is the function of that two pins. So what I will do, I will go on rubbing each pin as I explain, because that will sort out the things, that will make you appear little bit easy. So if you want to take the screenshot, you can take it now, as I have slided this way. So what is the function of XTAL1 and XTAL2? It is connected to the crystal. As crystal oscillates, there is some frequency. Higher is the frequency, higher is the speed of the processor. So what is the frequency here in microcontroller 8051? It is 12 megahertz. So that's it. And one more thing I want to tell, I had actually told in the first video, why is the name micro? Because see, frequency here is 12 megahertz. So what is time period? Time period is 1 upon frequency. So what is mega? Mega is 10 raised to 6. So if I want to calculate time period, this 10 raised to 6 will go upside and become 10 raised to minus 6, which is basically microsecond. That means an operations can be performed in this much time also, a microsecond. So that is why is the name microcontroller. So let me rub the two pins which we studied now. So reset pin. Now in the last video we discussed about memory. So there are some temporary functions stored on RAM and there are predefined functions stored on ROM. So if I want to clear all the RAM, what I will do? Set the reset button. So reset button will clear all the temporary memory, that is RAM, and will, like AC. Suppose you turn the temperature to 24 and by default AC shows the temperature of 16. So as you switch off, you basically set the reset button, which leads the AC to be in the default position as it was earlier. So that is basically the reset. It resets the microcontroller. So ALE bar. So what is ALE? It is address enable latch. So we will see that now. So to study this and this and this, we need to study all three. We need to have some basic knowledge of this. So again, as I said, I will not assume anything. So I will first complete that part and then come here. What is VCC and ground? This is basically high potential and this is basically zero potential. We know that current flows from high potential to low potential. So this is in one sense the supply of the battery, so which every device needs. This is positive, plus, and this is negative and minus. So here we completed 4 pins out of 40. In coming 5 minutes we will almost complete 70% of the more pins. So here microcontroller has 4 ports: port 0, port 1, port 2, port 3. Each port has 8 pins because it is an 8-bit microcontroller, and every pin is bit addressable. That means I can use each bit separately. Like here I can connect 8 fans, here I can connect 8 tube lights, here I can connect 8 devices more. So each bit is bit addressable, each port is bit addressable. But in real life we use microcontrollers in remotes and something like that stuff, in small stuff. So it is not necessary that at every time I will be using every port and at the same time I will be using every bit of every port. This is not actually possible. So every port is given some alternative function. Okay, every port is given some or the other alternative function, which I have written here. Okay, so let us see now alternative function. Now if you know about the architecture or you know about the basic of any microprocessor or microcontroller, or you have some pinch of knowledge of anything, any stuff like electronic stuff, you know that there are address bus, there is data bus, and there is control bus. If you don't know, I can tell you in short. So first, address is sent from the microprocessor or microcontroller, then that address comes, then data is sent, then control is sent, like to where data should be given. So to conclude, first address is given out and then data, because unless you know the address of something, you cannot send someone. First we want to know the address. Okay, yahan. So then we send the data. Okay, so that means address comes first or goes first and then goes the data. So in microcontroller we want to minimize the space, as we discussed in the first video. So since we want to minimize the space, then if I use separate space for address and separate space for data, then it will be useless, because first address will go, then address will come, for example, then data will come, right? So that is completely useless. So then why not use one pathway, address comes, data. So that function is there using port 0. So microprocessor 8051 controller I will many times repeat this mistake of saying the microprocessor, because it's actually a processor. It has everything, just it is embedded on a single chip. So that's why please resist that. So it has a 16-bit address bus. Address bus is always 16-bit, whether it is a microprocessor or it is microcontroller. So that 16-bit address, so what it will be A0 to A15. Okay, so that is converted into two separate buses, which will be A0 to A7 and A8 to A15. Okay, so address bus, a 16-bit address bus. 16-bit address bus means it will occupy 4 numbers, for in case you don't know. So 16-bit address bus is divided into two sections. Okay, this actually I am covering the basic part. If you already know this, then definitely you can forward the video, because these pins are way simple. Every pin is just one line and you will understand, okay, it was this, but basic background one should know. So address bus is divided into two parts. Now data bus we know that it is an 8-bit, so data will be definitely 8-bit, say D0 to D7. So what we do, we combine this data bus with this address bus and make a single pathway, as I explained now. So this will be completely called as AD0 to AD7. This will be completely called as AD0 to AD7, which in English is called as multiplexer. Not in English, but in technical language it is called as multiplexer. Means we multiply two buses on a single pathway. So that is the alternative function of port 0. So if there is some input output operation going on, then it's okay. Otherwise, alternative function is being a multiplexer. We can use port 0 as an address bus, also as a data bus. So that was the function of port 0. Alternative function of port 0. So that's it. 8 pins are covered. This was simple. 8 pins are covered. That was it. P1. Now since every port is given some alternative function, now suppose I actually strictly want to do input output function. These ports are all IO ports. I mentioned this in the last video. So suppose I strictly want to do input or output operation, and I want 100% result. Like this doesn't happen there. I supply something to port and that was doing some alternative function. I don't want that situation. So port 1 is only IO port. Only it can take data and it can receive data. It has no other alternative function. I hope this was simple. Port 1 has no other alternative function. So that's more 8 pins. So in this way we have covered the 16 pins, right? And few pins here. Now port 2. Now I told you that address bus is 16-bit, is divided into two sections where this is multiplexed into this. So what about this? So here it is covered in this bus. So this can work as an input or output port, or it is used to send the remaining address. So more 8 pins are covered. This much only was the function. Now P3. Now P3 has a variety of functions. So before that I may rub, because then that will appear easy, like, oh wow, we have understood this much. So I may rub every other thing. Sorry, not P3. So P3 is definitely an 8-bit port again, but it has a variety of alternate functions. So since it has 8 pins ranging from 0, 1 to 7, so 8 pins are divided into 2 pins, means into 4 groups of 2 pins each. So you can see group 1, group 2, group 3 and group 4. Now let us see all that. Receiving data, transfer data. If I want to receive data, and this is serial mode, okay, serial mode. Data can be transmitted to 2 modes, one is serial and one is parallel. In parallel, the data is sent through more lines. Suppose I want to transfer 3 bits. Okay, I have 3 bits in my hand. I want to transfer these 3 bits. So in parallel, we will transfer 3 bits at the same time to the location. But in serial mode we will transfer 1 bit first, then second bit, then third bit. So that is serial mode here. RxD stands for receive the data, TXD stands for transfer. Why it is named receive? Because we are seeing everything from the perspective of a microcontroller. So receive the data means microcontroller will receive the data, transfer the data means microcontroller will transfer the data. Interrupts. What is interrupt? Suppose you are playing a game and suddenly a call comes. So it is call for you, but what is that for a microcontroller? It is an interrupt. It was an unwanted thing which came. And similarly the message is also an interrupt. You are playing a game and it shows an interrupt. You are printing something on your PC, suddenly paper gets over. So PC displays an interrupt message showing that please enter the paper. So that all are interrupts which other things like call or other things will send to the microprocessor. So that is interrupt 0, interrupt 1, 2 interrupts. Timer. We started with this video being a timer. So this is somewhat different timer, like a oven. Oven wants to, suppose I said I want to, not this way, but I say that my food cook be should I want to set cooking time as 1 minute. So what is that 1 minute? That 1 minute is a timer. So we have a separate timer, like, okay. And there are two types of timer. There are two timers, not two types of timers. So in this way again 6 pins are over, so I can definitely rub them. So you can see now how fast everything is going on vanishing. So that's it. I may complete this line because that's so okay. Now everything is sorted out. Now there are few pins which are way easy. Now suppose I want to connect external memory. Now every mobile cell phone has an external memory feature, okay, but we always see that it is written like this cell phone has external memory expandable up to 64 GB. This pen drive, not pen drive, but this PC has an expandable memory of 4 GB, right? We see the limit. There is always a limit. This can be expanded until certain limit. So same way, if in case we need some external memory, we need some more memory, we can connect it externally, right? We can connect it externally. So how can we define the range of that expandable memory? So that is decided by the address bus. Okay, that is decided by address bus. So how many bit is the address bus? It is 16 bit. So what does 16 bit means? How much 16 bit means? So 16 bit basically means something like this much lines. This is a not this much, but this is 16 bit lines, and which answer, if we do all the permutations and all the combinations, if we look at 2 raised to 16, it will nearly come around 64 KB. It will nearly come around 64 KB. So that means we can connect external memory of 64 KB. Okay. Now again memory, there is either ROM or either RAM. So we can connect either 64 KB of, now okay, let me go little bit slow. So I can connect 64 KB external memory. Now there are two options. I divide this 64 into 2. I connect 32 KB of RAM and connect 32 KB of ROM and use them simultaneously. Okay, simultaneously I am using RAM, simultaneously I am using ROM. Okay, this was one option. The second option is I connect a 64 KB RAM and I connect a 64 KB ROM and I use them individually. When I am using this, I may not use that. When I am using that, I may not use this. So what is a good choice? So definitely this is not a good choice, because 32 KB is not a big thing and big issue, and we neither use both simultaneously. So this is not a good choice, this is a good choice. So for this again we have to have two pathways, two different separate pathways to use. So now I think every basic is clear. So let us come to now remaining 5 pins. I connect something external. Okay, I connect something external. If I connect external RAM, these two are the controlling signals for my RAM, for my external RAM. So when I will connect external RAM, I will send the signals through this pathway, either read, either write. Okay, so I hope this till now it is clear. Now what is PSEN bar? Now what remain here? PSEN bar means program status enable. So what is the situation of the program? That is PSEN bar. So that will be decided for ROM. So now I have two complete separate pathways for my RAM and my ROM. So what I actually did, I had actually connected 64 plus 64, which is 128 KB of external memory. No doubt I am using 64 KB at once, but actually I have connected both two. So read and write signals are for external RAM and PSEN bar is for external ROM. So I hope you have got these two also. Now this is ALE. What is ALE? Now we studied here that port 0 is from port 0 to port 7, pin 7 and carries an address, and it carries a multiplexer. Now at some point of time data will be transferred because it has a data bus. At some time address will be transferred as it is an address. Now address or data, what is this? These are basically a game of numbers, right? Data is also a number, address is also a number for microcontrollers or microprocessor. Now how this will know that whether it is a data or it is a number? So this is address enable latch. When this is 1, the thing which is going is an address, and when it is 0, it is data. Okay, so when it is 1, it is an address, when it is 0, it is an data. So in this way we can know this is an, by checking simply ALE we can know, okay, this is address or this is data. So I hope this all is clear. This is read and write signals are for external RAM. PSEN bar program status enable is for external ROM. ALE stands for address enable latch. So I hope everything is clear. So this is EA bar. EA bar is enable access. EA bar is enable access. Now we will see this in detail in the memory organization video, but for a while I may tell you enable external access. I forgot to write the main word, enable external access. Now things will come, situations will come where you want to connect external ROM and discard this. You will basically electrically discard it and connect the external ROM. So in this situation, whether to know we are using an internal ROM or external ROM, this is used. So what it says, enable external access. So if suppose this bar was not given, so enable external access, if this is 1, we can see that there is an external access and external ROM is used. So these signals are usually called as active high signals, because if 1 is there they obey, if 0 is there they does not obey, but this is an active low signal, so this will work in 0. So when EA bar is 0, there is an external access given, means we are using the external ROM. So I hope 40 pins are way clear to you. 32 pins are given to the, so let us just recap. So out of 40 pins there are 32 pins for ports. So port 0, 8 pins for port 0 used as a multiplexer. Address bus plus data bus is called as multiplexer. Further 8 pins for port 1 simply for input or output, simply for taking input and giving output. Port 2, the remaining 8-bit of the 16-bit address bus are used in port 2. Port 3 has 8 pins separated into group of 2. First was serial port data, receive the data, transmit the data. Second was interrupt, interrupt 0, interrupt 1, both active low like a dash here. Second are timer signals, timer 0, timer 1, and fourth is read and write bar for external ROM. Here we saw VCC and ground for the higher potential and lower potential. Here we saw XTAL1, XTAL2, which are connected to the clock. Then there was a reset to reset and clear all the random and temporary memory, not random but all the temporary memory. Then there was PSEN bar, which was for external ROM, and finally AEA bar for enable access for external ROM or internal ROM, whatever we are using. And last pin was ALE to tell whether there was the address was transfer or data. So I hope you clearly understood. If you have any suggestion, you can write in comments. If you want to give any feedback, you can write in comments or can send me personally on my number 8080891313. So I wish and I hope you understood from this video a lot. So consider subscribing if you like. So meet you in the next video. Thanks a lot.